Hello everyone, welcome back to Year in Mathematics. My name is Victor and today we're going to be learning about properties of quadrilaterals. So in year 7 we learned the names of quadrilaterals based on their outside edges. Today we are looking inside. We're going to classify them based on their diagonals, the invisible lines that connect opposite corners, as you can see right here. So let us start with the rectangle. Let's just zoom out right here, as you can see. So what did you notice? I'll give you a little bit of time. You can pause the video, that's fine as well. Okay, if you pause the video, as you can see, I'll show you that I already wrote them for you guys right here. Equal length, they bisect each other and not really at 90 degrees. So this is not 90 degrees, of course. But let me just say that they're the exact same length. Yes, they bisect each other and they can have each other as well. So you want to mark 4 equal lengths here, like this. 4 equal lengths. These are equally as each other. I'm going to put a single tick mark on all 4 halves of these to show that they are equal. Okay, let's go next to the rhombus. I pushed over square. You want to draw its diagonals here, and then are they the same length? No, because one is long and one is short. One long here, short here. Okay, but they do something special. They bisect each other, and they are actually at 90 degrees. So if you actually put a right angle square at the middle where they cross, and you put single ticks at 2 short halves here, and then double ticks on the 2 long halves here, and you get yourself a rhombus. That's for rhombus. What about the square? Now, as you can see from the square here, the square is a perfect shape. Because if you look at the conditions for everything of the summary table, are they equal to all these? Yes, they are all equal. The parts are equal. They bisect each other. They're all at 90 degrees. They're basically the perfect shape. Yeah, they have the best of both worlds, as we can see right here. Inherits both best properties of a rectangle and a rhombus, right, as well, as you can see. So I'll just annotate them here. They are all equal. They all have 90 degrees. And they bisect each other. Not much to it. Just as know that they have everything that you could possibly want in a shape. Finally, let's go into the parallelogram. They pushed over a rectangle. Now that the diagonals are not equal length. To be sure of that, they do bisect, but they are not at 90 degrees. They cut each other in half. Okay? This shape right here is not really that special. The parallelogram only bisects. Whereas with a kite, they do have a 90 degrees. They are not equal. They do bisect at each other, and they do cut this into half, which means that this is equal. Okay? But the long vertical one does not really cut into half. So only these ones are equal. And of course, when you want to really learn about shapes and everything, this is a classic in a channel. When in doubt, you need to draw them out, and then you need to mark equal lengths and the right angles, so you do not second guess yourself. Oh, this is a triangle. Then should I have a? No. You should try to look at a summary table, something like this, while you're drawing, and then mark them out, and then your doubts will be fully gone because you have drawn them out basically. So yeah, those are for the properties of quadrilaterals. I'll see you in the next video. So just sketch the shape, draw the diagonals, and let your eyes tell you like what's going on. Always mark the equal lengths, right angles on your diagram. Look at the summary table, double check. That's it. I'll see you next time.